Record. Okay, so this is a very long topic. So let's do an overview of what we're going to do. This is part one. There's two booklets. This is the first part of the booklet. We're going to look at a new way of measuring angles using radian. And we're going to explain what they are. And then you're going to find the exact values and solve trigonometry equations. And then we're going to look at area of the sectors, length of an arc, etc. So I'll put more detail onto what we do each lesson. So each lesson, it tells you what page number we're going to do in each lesson. So hopefully that will make it very clear. So today we'll do page 2 to 6, means 5 pages. Some lesson will do 4 pages, some lesson will do 3 pages. And that tells you what exercise to refer to. So sometimes you do 3 things, sometimes you do work from the booklet, sometimes you do an exercise from the textbook. Okay, so it tells you exactly what to do. Okay, we're going to move on to the next page. All right, we're going to look at a new way of measuring angle called radian. So what's a radian? Okay, so to answer this question, we're going to do some investigation. So we need to know 2 things. We need to know what's an arc length. An arc length is the length of this part of the circumference. And then we need to know what a radius is. Radius is this length here. That's called the radius. Okay, we're going to do some investigation. We're going to find a new way of measuring angles. And we're going to measure angles involving radius and the arc length. So we're going to compare these 2 sectors. So in these 2 sectors, both radius are the same. And the 2 arc lengths are different. One arc length is bigger than the other one. So what does it tell you about the arc length on the angle? So the bigger the arc length, the bigger the angle. Good. So the bigger the angle. Okay, good. So we see the arc length will make the angle bigger. What if I make the arc length the same? They're both 1 centimeters, but make the radius longer. What effect does it have on the angle? Makes it smaller, right? Just imagine that you're going away from a light source. The further you walk away, the smaller the angle it becomes. So we see the bigger the radius, the smaller the angle. So it looks like an angle depends on 2 things: the arc length and the radius. The arc length will make the angle bigger, the radius will make the angle smaller. So for this reason, the way to measure the angle is we divide the arc length by the radius. That's a new formula to find an angle. So it's L over R. Okay, now why do we do L over R? Let's use this formula to calculate angle alpha, beta, and theta. Okay, let's find alpha first using the formula above. So alpha, using the formula, will be arc length, which is 1 over 3. Yes? Arc length L over 3. So using the formula L over R is equal to 3 over 1, which is 3. No, hang on. It's 1 over 3. 1 over 3. 1 over 3. Right? Now, how about beta? Beta is 1 on... No, beta is this angle. 2 over 3. So 2 over 3. So clearly, beta is bigger than alpha, because the bigger the arc length, the bigger the numerator. So when the numerator are bigger, that makes the angle bigger, right? Now comparing with gamma, gamma will be, not gamma, theta. So theta is equal to 1 over 6. Clearly, theta is smaller than alpha because you have a bigger denominator. That's why we have the radius in the denominator, arc length on the numerator. So all these numbers are actual radian. And what's the symbol for radian? The symbol for radian is C. Right? Why is it called C? C stands for circular measure, because we involve the circle to measure the radian. However, we'll normally omit the C, because all we have to do, alpha equal to 1/3, when there's no unit, it means radian. If I write 30 degree, it means degree. But if I write 30, it means radian without the unit. So from now on, we're not going to write C each time. We're just going to write nothing means radian. All right, okay, so we're done. We know what a radian is. We know a formula for radiant. We're now going to convert radian to degree or degree to radian, because to make sense of radian, we need to connect with our usual sense of degree, our usual sense of angle, which is using degree to measure angle. So we need to see what does it mean to have a radian of 1/3, what does it mean to have a radian of 2/3. So we're going to link it back to degree. Okay, so hopefully you're all finished. Right, so the next question is, how big is 1 radian? Okay, how big is 1 radian? Okay, good. So how many degrees in 1 radian? So to answer this question, we're going to look at a circle. We're going to find the circumference of the circle. What's the formula for circumference? 2 pi r or pi d. We're going to use 2 pi r, okay? So 2 pi r, what's the radius of this circle? Radius is 1, right? That's your radius. This is 2 pi. Okay. Now let's calculate the theta in radian. Okay, so the value of theta in radian is using the formula L over R, right? Now in this case, what is L? The arc length. Well, the arc length is the whole thing, isn't it? So what's L? L is 2 pi, right? This is L. 2 pi over radius is 1, so just 2 pi. So theta in radian is 2 pi. But what's 2 pi? What's that in degree? 360, isn't it? So now we have a connection between radian and degree. 2 pi radian is exactly 360 degrees. Now I could divide by 2. That means pi is 180 degrees. So I could just divide by 2, right? Just half both. Not only I could divide by 2, I could also divide by pi. Why do I divide by pi? Because I get 1 radian, isn't it? So if I divide by pi, I get 1 radian, which is 180 over pi. What's 180 over pi? So we can work this out on a calculator. So now I could find out how big is 1 radian. The size of 180, one radian is actually pretty big, because 180 divided by pi equals to 57 degrees and 18 minutes. So 57 degrees, approximately 18 minutes. That's how big 1 radian is. It's very big. 57 degrees, that's 1 radian. Okay, now you need to remember this. Maybe not 57 degrees, but 180 over pi is 1 radian. Now, how do we make sense of this? So we can visually see what 1 radian is, because from the definition of radian, theta is L over R, right? So for this angle, what's this equal to? How many radian is this angle? It's 1 over 1, right? L, this is L, this is R, right? So 1 over 1, which is 1. That is exactly 1 radian. Now, I could draw a different shape, which is about approximately 57 degrees. Now let me draw another thing. Let's draw a triangle with 1 centimeter each. Now what do we know about this angle for an equilateral triangle? 60 degrees. Can you see why this is so big? Because it's almost the size of an equilateral triangle. So 1 radian is slightly smaller than the angle in an equilateral triangle due to the curve, because when you curve it, it makes this angle slightly smaller. Right? Can you see 1 radian? It's very close to 60 degrees. Okay, so that's how we make sense of the size of 1 radian. Okay, so let's go. Now we still have to work out a formula for the conversion, so let's work this out. Conversion between radian and degrees relate to so it's like the conversion between centimeters and meters. We can also have a formula to convert radian to degree. So what we do is we're going to go back to this. 1 radian is 180 over pi. So we write 180 over pi is 1 radian, which is about 57 degrees. 57 degrees. Now what if I want 2 radian? What do I do? I just double it, isn't it? So I just times that by 2. So I just double this one. That's about approximately 114 degrees, right? So what if I want to get theta radian? You times it by theta. So now we have a formula. So theta radian is exactly that 180 theta over pi degrees. So now we have a conversion. So to convert from radian to degree, we multiply by 180 over pi. And to go from degree to radian, we do the reverse. We divide by 180 over pi, or we can times by the reciprocal. Right, done. Good. So now we have a conversion. So we're going to use this formula to do some calculation. Okay, so which is on the next page. All right, all done. Okay, so example 2. On example 2, you should have a calculator ready for this exercise. If you need to borrow a calculator, please come to the front. There's some calculator available. Okay. All right, so we'll do the first question. We're going to find this in radian in terms of pi. So how do I get radian? To convert degree to radian, you times by pi over 180. Okay? Pi over 180. How do I remember it? So when you convert to radian, you want to get rid of the degree, so divide by 180, multiply by the pi. Okay, so what you do is, you're going to leave your answer in terms of pi, so therefore what you need to do is to write 495 over 180. You just have to simplify this fraction, press equal 11 over 4, so you write 11 pi over 4. Now, what if you put a pi next to it? If you put a pi next to it, it ends up giving you not this one. You end up giving you a decimal, 1 in terms of pi. So that's why you don't write pi on the calculator. Okay, so we'll get rid of that. Okay, next question. Convert that many degree in radian. So in this case, and they want you to round to 2 decimal places, so you just type this on the calculator. So you type in 73 divided by 180 times by pi. Actually, or you can just type this in, times by shift pi fraction 180. Yep, like that. 2 decimal places, so 1.27. 2 decimal places. Now notice that I do not put any units for radian. This means radian, but degree has a symbol, degree symbol. Okay, how about the next one? What's 0.3? What units is that? Radian, because it doesn't have units. So if you do it on a calculator, you do 0.3. So what's the working out? 0.3 multiplied by 180 over pi. Convert your answer to the nearest minutes. So you write 0.3 times 180 over pi. To the nearest minutes, press this button, degree minutes. So 17 degrees and 11 minutes. 17 degrees and 11 minutes. All right, all done? Okay, good. Now how about this one? Convert these to degrees. So you're going to write 3 pi over 4. to convert to degree, you times by 180 over pi. Okay? Now you see that the pi get cancelled. So you just find 3/4 of 180. So let's find 3/4 of 180. So write 3 over 4. Or you can type the whole thing in with the pi if you want, because the pi just get cancelled. Times by 180 over pi. Okay, like that, 135 degrees. And of course, if you don't have the pi, it won't make a difference. You still get the right answer because the pi get cancelled. Yeah, you still get 135. Okay, try the next one. 11 pi over 6 convert to degree. So you do 180 over pi. Alright, like that. So the pi get cancelled. 180 over 6 is 30. 30 times 11 is 330 degree exactly. Alright, now we know how to convert from degree to radian and also radian to degree. Okay. Alright, the next bit is very important. We need to know some exact ratios because in trigonometry, some angles are used more often than the others, like the special triangle, the 30 degree, 45, 60, all these are very important. So the same thing, radian, we need to be able to recognize them very quickly. So 180 is again pi, right? 180 is pi. So 30, let's start with 180. This is pi. Put pi there. Now 90 is half of 180, isn't it? So naturally, the radian will be pi over 2. That's 90 because it's half of 180. 60, what fraction is 60 of 180? What fraction? It's a third, right? So you write pi over 3. And then just compare 45 and 90. 45 is half of 90. So if you half of half, what do you get? You get a quarter. Yep, pi on 4. And 60, 30 is half of 60. What do? You do half of a third, which is pi over 6. And then this one, 360 is double 2 pi. And how about 270? 3 pi on 2. And you have to memorize them all. Memorize. Okay, how do I memorize? Just write them out many times. Write them out. Write them out. And maybe 5 times a day, you will remember them. Okay, or more. I think after writing it 10 times, you will remember them. It's very easy to remember. Okay, now, next we're going to look at trigonometric ratios. Okay, so what's 30 degree again? It's pi over 6. Just remember 60 has a smaller denominator because it's bigger. 30 degree has a bigger denominator because it's smaller. 45 is pi over 4. How do I remember? Just remember there's a 4 here. Okay? And then these two are swapped. So the next one is, so you need to remember what sine pi over 6 is, which is sine 30. What's sine 30? It is half. And the next one, sine 45, sine pi over 4 is 1 on root 2. Next one, sine pi over 3, it is root 3 over 2. So now you should be able to recognize this very quickly. So you have to practice doing sine pi over 6, sine pi over 4, and remember the ratios. Okay. Next one's cos pi over 6 is root 3 over 2. Cos pi over 4 is 1 on root 2. Cos pi over 3 is half. Okay, so you've got the cos. And then you also have the tan. Tan pi over 6 is 1 on root 3. Tan pi over 4 is 1. And tan pi over 3 is root 3. Okay. Alright, so again, that's another thing you need to memorize. Memorize. It helps you in the long term. Okay? Alright, so we've got 2 more pages to go through. Okay, this one you have to have a calculator with you because you need to understand the radian mode. If you don't have a calculator, please borrow one. Okay, so... Alright, next page. Okay, let's look at your calculator. Currently has a D on the top, means degree mode. So what we're going to do is, let's type in sine 30 degree. The answer is should be half, which is 0.5, as expected. The calculator tells you the right answer. Now remember what pi over 6 is. This is 30 degree, isn't it? Now let's see if your calculator gives you the right answer when you type in pi over 6. So let's type in pi over 6 in degree mode. It gives you 0.0091. That's in degree mode. Now, why doesn't it give you the right answer? The way to explain it is, if you type in pi over 6 on a calculator, let's type in pi over 6, you will get the answer 0.5235. 0.5235. So what the calculator do is, it calculates what pi over 6 is, converts to 0.5235, and then calculate 0.5235. And if you do that on a calculator, it gives you sine 0.5235. It gives you 0.91, 0.0091. So it doesn't recognize this is radiant. It just reads it as a degree. It reads it as 0.5235 degree in degree mode. Right? It just automatically assumes this is a degree you're giving the calculator to. So how do I fix this problem? You can fix this problem there are 2 ways. I'm going to show you one way. One way is to convert it to radian mode. So if you press shift mode, okay? Press shift mode. So I'm going to write shift mode like this. You will get number 4. Option number 4 is radian mode. Rad. Okay? So if you press that, you will see the top bit becomes radian. So if you type in pi over 6 again, it should work. It should give you the expected answer of 0.5 in radian mode. So sine pi over 6 will give you 0.5 in radian mode. Okay? Now once it's in radian mode, if you give an answer in degree, it will no longer work. If you write sine 30, it reads it as sine 30 radian, which gives you a different answer. Okay? Alright, that's one way of doing that. Let me show you another way of doing this conversion. So one way is to change the mode. And if you want to change it back to degree mode, you can just go shift mode 3. Okay, change back to degree mode, it gives you 0.5. Okay, what's another way to do that? Let me see if I could see the button. Radian. There used to be button. Oh, there it is. Maybe this one. Okay. All right. So we're going to do it in a different way. Okay. So let's go back to sine pi over 6. Now, as you can see, if I do sine pi over 6 in degree mode, it doesn't give you 0.5, isn't it? But you can insert a radian symbol. Now, how do I insert radian symbol on your calculator? Press shift. See the answer on the top, it says DRG, degree radian. Okay, so you can go shift this one. See the R there, means radian. Press 2, gives you 0.5. Okay, so that's another way. So you can do radian stuff in degree mode as long as you put in the right units. Okay, so you have to put shift answer. Okay, shift answer. And then you just choose the symbol number 2 for radian. So if you put an R there, it gives you 0.5 in degree mode. Okay, get the idea? So there's two ways to do that. And you can use either way, but you just have to be careful. If it's in degree mode, if you put a radian symbol. Now you can also do the same thing in radian mode. So if I press shift mode, put it in degree mode, radian mode, actually it makes no difference. But if I put 30 degree in radian mode, it doesn't give you the right thing. It treats it as 30 radian. So all you have to do is just put a degree symbol there. Degree symbol 1 gives you 0.5. Okay, so you can just put the right symbol, then it will give you the correct answer, despite in the different mode. Okay, but if you get rid of the degree, it will give you the wrong thing. Okay, let's go back to degree mode again, because that's more useful. Okay, all right, so let's calculate this. Example 3, cos 2. Now, C2 doesn't have a degree symbol, that's in radian. So what you need to do is just put your calculator in radian mode, shift mode 4, and press cos 2. You get negative 0.416, negative 0.416, 1. Correct to 4 decimal place. Okay? Or you can do, that's in radian mode. Or you can do it in degree mode. In degree mode, what you need to do is to press shift mode. Let's go back to degree. Now it doesn't give you that, right? It gives you a different answer. So what you need to do is just press shift that one, radian. Cos 2 radian equal, gives you that. Okay? Alright, so degree mode, you just press cos 2 with that little r on top. Okay? Okay, after this, can you please try to practice this again? Hopefully remember all these exact value. Try to do that again. See if you remember, that's in random order, so that will test your knowledge of this exact ratio. Can you fill this out? So I start off the first one, that's half. Do the rest. Okay, good. Let's go through the answers. So hopefully you got all of them. So first one, cos pi on 4 is 1 on root 2. This is half. Root 3 on 2, root 3, 1 on root 3, that's 1 on root 2, and root 3 over 2. So if you memorize them, you can do them very quickly. Okay, good. Any question? No, this one not important. This is more important. Know this. This will help you a lot in the exam and in the exam. Okay, all right, good. Let's work out this exact value, 3 cos pi over 6. So if you know what cos pi over 6 is, this is what's that? It's root 3 over 2. So write root 3 over 2 multiplied by 3 minus, what's cosec equal to? 1 over sine. So write 1 over sine pi over 4. Now going back to the table, what's sine pi over 4? It's 1 on root 2, isn't it? So you reciprocal 1 over root 2. And if you reciprocal that, what do you get? Just root 2. So you get equal to 3 root 3 over 2 minus root 2. That's it. You can't simplify further. You can make a common denominator, but I don't think it's necessary. Okay, good. Any question? All right, after we finish, let's look at this diagram. This is a very important diagram. So normally you're accustomed to doing 0 degrees, 90 degrees, 180 degrees, 270 degrees to work out which quadrant you answer in. Now we need to be able to work out from radian without converting back to degree, because that would take you a long time. So let's look at how the angles are increased. So going back here, this is, okay, so 90 degrees is half a pi. So just think about 0.5 pi, 0.5 pi. And every time you go 90 degrees, you add half a pi. And then you add another half a pi to get 270, add half a pi to get 360. Okay, just remember, 0.5, 1, 1.5, 2. That tells you which quadrant it is in. So let's look at the next page. We're going to find out what quadrant they belong to. So we're going to look at the first one. To find out what quadrant 2/3 pi belong to, just convert 2/3 on a calculator. What's 2/3 on calculator? 2/3, that's about 1.6, right? 0.6, so you press this button. 0.6, okay. 0.6, approximately 0.6 pi. So what's 0.6? Go back to the last page. 0.6 is between 0.5 and 1, right? So that means that tells you which quadrant. Second quadrant. So you draw this. This is 2 pi over 3. Because 0.6 is between 1 pi and 0.5 pi, right? That's how we know which quadrant it belongs to. Now, try to find out where this is. All right, 7/6. What's 7/6? 1 point something. Yeah, so we know 7/6 is going to be less than 1.5, isn't it? So you know it's going to be between 180 and 270. So press that, equal, press SD, 1.16. So we know it's going to be in the third quadrant, right? Because it's between 1 and 1.5 pi, right? This is 1.16 pi. So it's in the third quadrant. All right, how about the last one? 7 pi over 4. 7 over 4 is in radian. Radian will be 7 over 4. That's about 1.75. So between 1.5 and 2 pi, right? So it's in the fourth quadrant. 7 pi over 4. Okay, after we do this, now we have to find what we call the related angle. Related angle. Now, what's that in related angle is this angle. The angle makes with the x-axis, the acute angle. That will help us to find the ratio. Now, how do I find the related angle? Now, with degree, we'll do 180 minus. But for this one, you just go to get the related. You just have to do pi minus 2 pi over 3. Now, do you do that on a calculator? No, you don't do that on a calculator because it gives you decimal. So just do 1 minus 2/3. Or if you can do it in your head, you know it's going to be 1/3. So there's no going to be pi over 3. That's your related angle. Pi over 3. Okay? Pi over 3. All right, next one. How do you find the related angle for the next one? You do the same thing. You do, because it's a bit over 180, you do 7 pi over 6 minus pi. So related, 7 pi over 6 minus pi. So it's like doing 7 over 6 minus 1. Minus 1, you get 1/6. So you get pi over 6. Right? Pi over 6. And then how about the last one, related? Pi on 4, no. Pi on 4. How do you get pi on 4? You just go 2 pi minus 7 pi over 4. So it's like doing 2 pi is like 8 over 4. So you do 2 minus 7 over 4. You get pi over 4, right? Pi over 4. Pi over 4. Okay, so after finding all of this, you can then find the exact answer. Let's do an example. Let's do this. Sine 5 pi over 4 in exact form. So how do I do that in exact form? The first step is to find the quadrant. Now, which quadrant is 5 pi over 4? 5 over 4 is 1.25, so it's between, yeah, right? 1 and 1.5, so it's 5 pi over 4. Like this. And then we find the related angle. Related angle. And what's the related angle? You subtract this angle by pi. So it's like subtracting 1 from 5 over 4. What's 5 over 4 minus 1? Yeah, so how do I do that so quickly? You just go like this. You just make a common denominator. So it's pi over 4 left. Right? That's pi over 4. Okay, we need both the related angle and the quadrant to work out the answer. So what you do is, you go like this. You have to go sine 5 pi over 4 is equal to, in the third quadrant, sine is positive or negative? Negative. So you go negative sine of the related angle. That's why I want to calculate the related. Now, what's sine pi over 4? We just try to learn the table. If you learn the table, you know what sine pi over 4 is. What's sine pi over 4? 1 on root 2, and then sine 45, which is 1 on root 2. So you get the answer. Now, I haven't shown you the other way. The other way is to convert everything to degree, which can be wrong. So it can be very long. So 5 pi over 4, so you have to do the extra step of convert 5 pi over 5 pi over 4 times by 180 over pi, which is 225. And then after you do sine 225, you draw the quadrant over here. And then find the related angle, which is 45. So sine 45. I don't know. I think it can be longer because you have to do extra conversion. Okay? So try not to convert each time. Just do it like this. Work directly with radian. I think that will help you in the long term. If you always convert to degree, you have to do more work. Okay? So it's better to use the radian, find out the quadrant from the radian, and then express the related angle in terms of radian. Okay, now we have 3 extra practice questions for you to try at the bottom. Use the same method. Find the quadrant, find the related angle, and work out what that is. Okay? All right, have a try. Now notice that these angles are exactly the same angle we just found earlier, which is with the on the top, the same angle, right? So we got the quadrant, we got the related angle. You can just copy them down. So the first 2 pi over 3 is in the second quadrant with the related angle pi over 3, as we found earlier. And then what you're going to do is you write cos 2 pi over 3. In the second quadrant, cos is negative with the related angle pi over 3. Now, if you remember the table, you will find this easy. What's cos pi over 3? It is half. All right, try the next 2 as a practice. So we'll do the next one. So the next one is in the third quadrant, 7 pi over 6. So with the related angle pi over 6. So we go tan 7 pi on 6, which is positive tan of the related angle, because in the third quadrant tan is positive. Pi over 6. And what's tan pi over 6? It is 1 over root 3. So memorize the special ratio. And the last one is in the fourth quadrant with the related angle pi over 4. So sine 7 pi on 4 is negative sine of the related angle. Sine pi over 4 is 1 on root 2. Okay? Alright, so what you need to do today, there are 3 things you need to do today from this. Okay, so you need to do 3 things. You need to do 5.1, which is very quick. 5.1. So there's a lot of questions. Just do ACE from each question. ACE. Okay. And then you have this worksheet which I just provided to you. Just do question 15 to 38. And you can do more if you want to, but you don't have to do all. You just do these questions. So that gives you a lot of practice. And the third thing you have to do is from the textbook again, exercise 5.2. Yeah, so there's some good questions you could try. Okay? All right, just do 3 things and start this now. Thank you. Freeze.